So today is your final roadmap before you take your final quiz on Wednesday. You probably already noticed that there are all of your anchor charts that we have already looked at these past 7 weeks over virtual learning on your Google form. However, I wanted to make sure that I was reading aloud the important information because I know some of you are auditory listeners and learners, and so I wanted to make sure that you didn't only have a visual, but you heard me saying these vocab words one more time. However, if you feel confident that just looking at those anchor charts is review enough for you, then you may move on to the questions. They will be there for your reference as well. You will have practice problems over all of this content, and you should expect to have at least one question over all of these topics on your quiz on Wednesday. So looking at our first anchor chart, remember back to the beginning of virtual learning, we were talking about organizing data. So the ways that we were organizing data was taking a data set or a list of numbers and finding the mean of that data set. Not sure what just happened there, but bear with me. So if we have a list of numbers or pieces of data in a data set, finding the mean is when we find the sum of the numbers in the data set and then divide by the total amount of numbers in the data set. As a refresher, there is an example here. So if you were to find the sum of a data set of 1 plus 4 plus 9 plus 7 plus 9, you get 30. And then you need to divide by the amount of numbers or the amount of pieces of data in that data set. So in this data set, there are 5 individual numbers or pieces of data. So you need to take 30 and divide it by 5 to get 6. So 6 is the mean of the data set. The mean of a data set is also known as the average. So if you're ever asked to find the average of anything, you are going to add up all of the pieces of data and divide by the number of pieces of data. Again, I put an example here that we're not going to go through again, but you can do the same exact process as above, these 3 steps, if the pieces of data are in fraction form or decimal form or a combination of them. Another way that we organize data is by finding the median of the data set. The median is the middle value of a data set when the numbers are arranged from least to greatest. So for example, if we are given a data set like this one, the first thing you need to do is order it from least to greatest, so smallest to largest, and then find the middle number. As a reminder, if your data set has an even number of data points, find the mean of the 2 middle values. So if you don't have just one digit exactly in the middle of your data set, you will need to find the average of those 2 middle numbers. In our 3rd week of virtual learning, we were looking at data displays. So this means we were looking at data in a visual way. So we weren't just looking at a data set, but we were looking at data in an actual display. So some of those data displays we talked about were histograms, which is a graphical display where the data is grouped together in ranges and then plotted as bars. So remember, histograms is in ranges of numbers. So when we have a number line and we have pieces of data, they are in ranges. So all of the bars were exactly next to each other. There was no space in between them. Okay, so that's a histogram. A bar graph is a graph using rectangular bars to show how large each value is. So if we're looking at a bar graph, there is space in between because we are talking about individual values for each bar. Then we looked at pictographs, which is a way of showing data using images or pictures. Each image stands for a certain number of things, and the way we know what each picture represents is because that data display should also have a key. Saying that, okay, if there are pictures of strawberries on my pictograph, I need to know, does one strawberry represent buying 1 pound of strawberries or one single strawberry? Once we looked at data displays, we looked at a specific type of way to organize our data even further. So we had already gotten used to ordering our data from least to greatest, and now we were able to look at the interquartile range. So we were splitting our data into quarters. Quartiles are the values that divide a list of numbers into quarters or 1/4 size pieces. So as always, you need to order your numbers from least to greatest, and then you are going to split your numbers into, your data set into quartile 1, quartile 2, and quartile 3. The first thing that we do is always find quartile 2 because that is the median or the middle of the data. Then we find quartile 1, which is essentially the median of the lower half of the data. Then we found quartile 3, which is the median of the upper half of the data. The whole purpose of doing this is to then find the IQR, or the interquartile range. The interquartile range is the range or difference, so we'll have to use subtraction, between quartile 3 and quartile 1. This portion is representing that middle 50% of your data set. Remember that we will not always have a number directly in the middle of a data set, just like we learned when we were finding the median for the first time. Sometimes a cut happens in between two numbers, and the quartile is the average or the mean of those two numbers. So looking at this example, if we're looking at this data set here, the median or quartile 2 is going to fall between 5 and 6. So I need to find the middle of 5 and 6, or the mean. So when I add 5 and 6 together, I get 11, and when I get 11 and divide it by these two pieces of data, I get a quartile 2, or median, of 5 and 5/10. And again, the same information is used to find my interquartile range, which is the difference between quartile 3 and quartile 1, because we are trying to find the value of that middle 50% of the data set. Once we had learned to analyze a data set and find the interquartile range, we also learned a way to display data and to display 5 specific pieces of data. We did this with a box and whisker diagrams. So the reason we had 5 specific pieces of data is because all of these pieces of data are represented in any box and whisker plot that you see. So, for example, the 5 number summary are the 5 pieces of data that you need before you can draw a box and whisker diagram. So the first thing you need is the minimum value, sometimes referred to as an extreme. So the minimum value is just the smallest number in your data set. Then you need to know your lower quartile, or your quartile 1, which again is the median of the lower half of your data. Then you need to know the median of your data set, or quartile 2. Then you need to know your upper quartile, or quartile 3, which is the median of the upper half of your data. And then you need the maximum value, or the largest number in your data set. Depending on the range of your numbers, that'll depict how large these pieces are. However, the overall shape is going to look just like this one. As a reminder, the furthest point to the left is your minimum. The dot furthest to the right is your maximum. The vertical line in the middle is your quartile 2, or your median. And the outside of the box on the left is your quartile 1, and the outside of the box on the right is your quartile 3. The box portion is the location of the middle 50%, so right here, of your data, and then the whiskers are representing the spread of the overall data. And then finally, this past week during virtual learning, we looked at the MAD, the mean absolute deviation. So the mean absolute deviation is the average of the positive distances of each point from the mean. So this is definitely one of the most challenging topics of 6th grade. But I was very proud to see how many of you showed so much grit with this concept. So this is a big one that I want to make sure we review before your quiz. So one thing is, this is a way for us to find the variability in the data. So the greater the variability in the data, the larger the MAD, the less useful the mean is as an indicator of the data values. So what this means is the more variability in the data, the less we can rely on that average number, because it means our data is super spread out. So ways that we are, or other concept that we are going to use to find the mean absolute deviation is the mean, which again is the average. Then deviation means the difference between a data value and a set and the mean of the set. As a reminder, absolute value, a concept we talked about before spring break and virtual learning, is a number's distance from 0 on a number line. So remember, this is always a positive value because you cannot have a negative distance. And finally, here's that word again, variability refers to how spread out or clustered the values in a data set are. High variability means the data is spread out, and low variability means the data is clustered together. So if we are looking at a spread of data and it's all over the number line, that would mean there's high variability. And then if we look at a data set where it is all clustered together for the most part, this means there's low variability. And finally, how are we actually calculating the mean absolute deviation? There are 3 steps that you need to follow. The first thing is you are going to find the mean of all of the values. So what is the average of your data set? Once you have the mean of your data set, you're going to find the distance of each value from the mean, aka you are finding the absolute value. So remember, the absolute value of a negative number is always a positive number because distance is a positive measure. The way that you can do this is subtract the mean from each value and ignore the minus signs. Remember, we have not worked with calculating positive and negative numbers, so I'm not going to make you do this here. And the third thing is you are then going to find the mean of those distances. I provided this example down here that you saw last week, and it is also going to be provided on your Google form. Remember, even if I don't ask you to put it in a display like the table down here, I think it is a useful tool to help you to write your value, write the distance that value is from the mean, and then find the mean of all of those distances. And remember that your mean absolute deviation tells us on average how far all of these values are from the middle of the data set.